Hello, I'm Jeff Hannon, Eastern District Manager for Engineered Systems. Here we are back at the priming tower, and what we want to show this time is what effect entrained air can have on a pump suction line and the performance of a pump. A lot of times in wet well design, you'll have an invert that's dropping water into a wet well, maybe a couple hundred gallons a minute, dropping from 8 or 10 feet in the air down into the wet well. That water splashing into the wet well creates a lot of turbulence, creates a lot of air that gets trapped in the water, and if that's occurring very close to the suction line or very close to a submersible pump, that air can sometimes cause a submersible pump to become airbound and lose its pumping capability. It can also introduce so much air on the suction line of the pump, cause the pump to be airbound. And to demonstrate that, we're going to go ahead and start this pump up, and then I'm going to direct the discharge line by opening a valve. I'm going to direct my discharge over near the suction of the pump. And by opening the valve, we're going to direct some flow and direct it directly at our suction line. You can see a lot of air in the water, you can see a lot of turbulence there, and a lot of those air bubbles are getting picked up and sucked up the suction line and going right into our pump. And you can hear the pump. There's a little bit of noise associated with the pump now as the air is working its way through that pump. There's a hydraulic imbalance inside of the pump now that over time could cause some bearing issues, but more importantly, it could cause the pump to lose its prime. Now, this is a self-priming pump by Gorman-Rupp. It's designed to handle a certain amount of air, so it can take care of a lot of air and keep itself pumping. But you can occasionally hear it coming in and out of a partial prime situation. If this were a submersible pump, and when the air would get underneath the submersible, it could cause that submersible pump to be airbound almost immediately and stop the flow coming out of the pump station. And that pump would trip out on a high temperature. But again, in the smaller wet wells especially, where an invert is dropping near a suction line, the splashing of the water can cause you some problems in the pump station. In conclusion, air entrainment is something to be mindful of in a wet wells, especially the smaller wet wells where you're having the invert dropping in there, the two suction lines. Typically, a good way to determine if entrained air is causing your pump to lose its prime. If you only experience the problem with one pump shutting down on high temp, the other pump whose suction line is further away from the invert or where the splashing of the water in the wet well is occurring, if that pump is working without any problems, then typically it's a good indicator that you might want to redirect the flow of water into the wet well away from that suction line and make sure that that pump's not getting too much air around the suction line because of the splashing of the water. Thank you.
For more information on pump hydraulics, equipment, or application engineering, watch Gorman-Rupp's YouTube channel and visit us at grpumps.com.